Let's go to page 388. This is lesson 6.5, and this lesson is to prove triangles similar by SSS and SAS. Okay, now remember, in congruence, they have to be congruent, right? But for similar, they have to have the same scale factor or the same ratio. So SSS means that all three sides have the same ratio. Okay, if they are exactly the same, then they will be congruent instead of similar. Okay, and again SAS, okay, the side have a same ratio as this side, and the angle in between is congruent. Okay, so that's your theorem. Okay, so in addition to use congruent corresponding angles to show that two triangles are similar, you can use proportional corresponding side length. Okay, so theorem 6.2, side. So SSS, similarity theorem. In the corresponding side length of two triangles are proportional, then the triangles are similar. So you got two triangles. So if every pair of corresponding angles have the same scale factor, then they are similar. So like if AB over RS, so AB over RS equal to a ratio that is equal to BC. Let's say this is 2 times as that. So if this is 2 times as that, and this is 2 times as that, this is 2 times as that. So all of them have the same ratio of 2 to 1, then they are similar. Okay? So that's what they're saying. So again, if this over this equal to this over this equal to this over this, okay, so all of them have the same ratio, then they are similar. Okay, example 1 is the SSS similarity theorem. Okay, is either triangle DEF or triangle GHJ similar to triangle ABC? So are they similar? So what you want to do is, again, there are different ways you can do this. Okay, so what you can do is make sure you match up the shorter side with the shorter side, and then the medium side with the medium side, and the longer side with the longer side. Make sure you match up carefully. Okay, or you notice in the book they use coloring, right? Now another way you can do this is by reduce the side to the lowest length and see if they have the same ratio. Okay, so let's go in 2 different ways. So you want to see if this is similar to ABC. So if this is similar to this or this is similar to that. Okay, so let's go and see. So let's go and do the. Let's see. They use the compare. Okay, so this over this is 8 over 6. Okay, so AB over DE is equal to 8 over 6 equal to 4 over 3. Okay, so that's a shorter side. And let's go and do the medium side. Okay, so BC, so that's the green, so it'd be EF equal to 12 over 9. So you're going to get 4 over 3. Okay, and then you do the longer side. So you got AC over DF. Okay, so AC is 16 and DF is 12. Okay, so you're going to get divided by 4, you get 4 over 3. So all of them have the same ratio. So yes, this is similar to this. Okay. Now another way you can do this is by listing them. Okay, in order. So you got like this one, you got 8, 12, 16, right? So so all these are divisible by 2. So reduce by 2, you get 4, 6, and 8. Reduce by 2, you get 2, 3, 4. Okay. Then now for this triangle, so this is a second way to check, see if they're similar. Okay, so you got 6, 9, and 12, right? For this one, again, reduce as much as you can. So divide by 3, you get 2, 3, 4. So you can see this number right over here and this number over here. If they match, okay, that means they are similar. And the scale factor would be the number on the side, see? It's 4 to 3, see? 4 to 3, so 4 to 3. So 2 different ways you can do it to check if they're similar or not, okay? By reducing as much as you can to the lowest number, if they match, means they are similar, okay? And the factors will give you the scale factor or the ratio, so it'll be 4 to 3, okay? Or you can do it this way. You can do each side individually, but the key is make sure you do it in order so you don't make a careless mistakes. So normally I like to do the shortest one, the medium one, and the longest one. Do it in order, okay? That way to avoid messing it up, okay? Now since we already did this, I'm going to do this one over here, okay? I'm going to do the 8. I'm going to do the 8, 10, and 16. Okay, I'm going to do this triangle. Again, if you reduce by 2, you get 4, 5, 8. And that's it. You cannot reduce anymore. So this does not match. Okay, so this is not similar to that. Okay, so that's how you do it. Again, if you do it individually, you can see they're gonna have all different ratios. Okay, and so you can do it right over here. So the short side has ratio of 1, longer side has ratio of 1, but the medium side has 6/5. So they didn't match. Okay, so this did not match, so this is not similar. Right. So again, there are different ways to check. Okay, so you can do it either way. Personally, I kind of like this method. This is more obvious, and this one you kind of have to be careful how to match up correctly. Okay. Okay, let's go to page 389, SS similarity theorem. So you have to prove. Okay, so giving. So you got RS over JK. So this over this. So the giving, so you got 3 pairs all giving, right? So right away you can know that this small triangle and the big triangles are similar. Okay, you want to prove that the triangle RST, the triangle RST is similar to that, right? Okay, so the way to prove this is locate P on the RS so that PS equal to JK. So what you do is you copy this length over here so that JK, so locate a point so that this length and this length are equal. Okay? And you draw the PQ so that it's parallel. So you draw a parallel line to that. Okay? Then triangle RST is similar. So triangle RST, so RST is similar to PSQ. They are similar because if you draw a parallel line, okay, then you're going to have the corresponding angles are congruent, corresponding angles are congruent, also the reflexive, okay? And so you can see that these two triangles are similar, okay, because of the AA theorem, okay? And so you can see that they are similar. So by AA symmetry, so because of the, and also, so you can see that these two are similar, right? And also, because of they are similar, you can write this ratio, okay? From, because similar triangle, you can write the ratio, right? So you got the RS over PS equal to ST over SQ, and equal to TR over QP, okay? So once you know that these two are parallel, you can write this ratio. And you can use a given proportion, the fact that PS equal to JK, right? See, PS equal to JK. And you can conclude that SQ is equal to KL, okay? Okay, so because when you do this, right? Okay, it's because these two are congruent, and you can see that these two are also congruent by the SSS congruent postulates, okay? So anyway, so by SS congruent postulate, it follows that triangle PSQ, so PSQ is congruent to JKL, and you do the substitution, okay? Okay, now let's go to example 2. Use SS similarity theorem. It says find the value of X that makes triangle ABC is congruent, similar to triangle DEF, okay? Okay, so by looking at the shapes, right? So they match the letters, right? So watch letter carefully. So A match with D, right? A match with D. B match with E. C match with F. So this already matched already. So you can see that this is 4, this is 12. So this is 3 times as that. Okay? So if this is going to be 3 times as that, so if this is 18, this would be a 6, right? So x minus 1 equal to 6. So that means x equal to 7. Okay, and you also can check over here. Okay, remember this is 3 times as that, so this would be 3 times as that, and you can divide by, so this will equal to 8. So again, x equal to 7. Okay, so this equal to 3 times that, so this equal to 3 times that, so this equal to 24. So you solve. Okay, and again you can do math yourself, right? You can just set it, just go and set it that this is 4 over 18 equal to x minus 1 over 12. You can do all that, okay? Okay, let's go to the next theorem. Okay, on page 390, the sine angle side SAS similarity theorem. Okay, so when you have two triangles, okay, that if the side have a certain scale factor compared to this, so these two sides have the same ratio as these two sides, okay, and the angle in between them are congruent, okay, and then they are similar, okay. So again, if angle x is congruent to angle m, okay, and zx over pm equal to xy over mn, okay. So again, so these have the same ratio as that, okay, or same scale factor as that, and the angle in between them are congruent. So that's your SAS similarity theorem. Now, if they're congruent, then the triangle will be congruent by the SAS, right? Okay, example 3 is a SAS similarity theorem. Okay, so link to shelter. Okay, you are building a link to shelter starting from a tree branch. Okay, as shown. Can you construct the right end so that it is similar to the left end? So right end similar to using the angle measure and the length shown. Okay. So over here, so you can see the angles are congruent, and so notice that this is 6 and 9, so this be 3 to 2, right? So 3 to 2. So that's what you need to have. Okay. Okay. So again, measure. Okay, both measure angle A. Okay, and angle F are 53 degrees. So the angle A is congruent to angle F. Next, compare the ratio of the length of the side includes angle A and angle F. So compare. So they use the AB over FG, right? So 9 to 6, right? So 9 over 6 equal to 3 over 2. The longer side is 15 over 10, so it'd be 3 to 2. Okay. So the length of the sides they include angle A and angle F are proportional. So by SAS similarity theorem, triangle ABC is similar to triangle FGH. So yes, you can make the right end similar to the left end of the shelter. Okay, so concept summary. Okay, triangle similarity postulate and theorems. So AA similarity. So again, if two pairs of angles are congruent, obviously the third one will be congruent also. So that's your AA. So they are similar. Okay, SSS. Okay, so if all three pairs of the triangle have a same scale factor. Okay, just like if this is twice as that, this is twice as that, this is twice as that, then SSS would be the theorem. Okay, and you got SAS. So you got angle congruent, and the side that include the angle have the same scale factor or same ratio. So if this is twice as long as that, this is twice as long as that, for example, and the angle in between are congruent, then that's your SAS. So there's are three theorems to prove they are similar. Okay. Okay. Example 4, choose a method. Here, what method you would use to show that triangles are similar. Okay. Okay. So in this case, you would use the SAS because see you have vertical angles. Okay, so vertical angles are congruent, right? Okay, and notice that the ratio of this would be the short side. Now you want to compare the short length with the short length. So 9 to 15, okay, and 18 and 30, okay. And you can see that, right? See, this is twice as that, and this is twice as that. Okay, remember when you're doing the ratio, you can compare that, or you can compare these, right? So if you compare that, this is twice as that, and this is twice as that. Okay, so they have the same ratio, right? So you can do that also. Okay, or if you don't like that, you can do the 9 to 15. Okay, if you double that, okay, then you get 18 to 30, right? So this is the double of that. So they have the same ratio. So you're going to have the SAS, right? Okay, so you can do that. So you can shorter side. Okay, you got BC over EC is 9 over 15 equal to 3 to 5. The longer side, CA over CD is 18 over 30 is 3 to 5. So you have same ratio, so that's your SAS, right? Okay, so the corresponding sides lengths are proportional. The included angle ACB and DCE are congruent because they are vertical angles. Okay, so the triangle ACB is similar to triangle DCE by the SAS.